Now that we have talked about generic types, the next thing we're going to do is talk about generic methods. So this is a second Java construct where we can actually introduce genericity. So what are generic methods? Generic methods are, as the name implies, methods that introduce type parameters. So the same way that you were capable to say my class, for example, something is going to accept a type parameter t, and when I construct object of the class something, I'm able to specify what I want t to be, like for example integer or double. Well, now you can do that also with methods. So it's really similar to declaring a generic type. The syntax is going to be very similar. We still use those angular brackets, okay? The main difference is that the type parameter scope is limited to the method where it is declared. So the same way that when you say, you know, I'm writing a class something, and this class something accepts a type parameter t, you can use that type parameter t anywhere in the class itself, but not in another class. Same thing here for method. The scope is different. Instead of being the scope of the entire class, it's the scope of a method, a single method only. So you can use these constructs in static and non-static methods. You can use them also in generic class constructors. So we are going to try to look at this with a few examples, okay, to illustrate what we can do. So let's start with some code here. We have a class named util, and this class util contains one static method so far. Okay, so util stands for utilities. So we are trying to put inside of one class, you know, a bunch of static methods that are going to be useful in our code. The first one, compare here, the only one that we have right now in the class, returns a boolean. So nothing really special there, but accepts two type parameter k and v. So you can tell already it's going to have to do with continuing a little our example from the pair interface and the ordered pair class, right? So we actually take two type parameter k and v, and then we take as parameters of the method itself p1, which data type is pair of k and v, and p2, which data type is pair of k and v as well. Okay, so given the type parameter, you realize that you can compare actually with this method potentially any sort of pair of whatever data type k, whatever data type v. Okay, all that matters is that if you are comparing two pairs object p1 and p2, they are instances of the same class, pair of k and v, whatever k and v are. Okay, so you cannot have comparison of a pair of strings and integer with a pair of double and integer, for example. The code itself, relatively easy. We call getKey on p1, and then we test if it's equal to the key that we receive from calling getKey on p2. And then logical AND operator here, we do the same thing with p1, p2, and getValue. Okay, so two objects of class pair kv are only equivalent if their key are equivalent and their values are equivalent. So nothing really difficult here. Let's move on to the next part of our example. Now we're going to go real quick on this side over the class pair. So we define a class pair, okay, so we moved away from having an interface. Now for this example we are going to just use a class pair, pair of k and v, so it works the same way than we saw before, and we have two attributes, key value, just as before. We have a constructor, just as before, and then we have two more methods than our previous example. So we still have the getKey and getValue accessors, but in addition we have two mutators, two setters that are setKey, setValue, and they work exactly as you would assume they work. Okay, they take a parameter, assign it to the corresponding field. So this is actually the class pair we are going to use in this example. So now that we have this class util and that method compare, that static method compare in it, that's supposed to be able to compare two pair, and now that we have defined the class pair, what it looks like exactly, then let's try to use this code. Okay, so in this slide you can see that we have two reference variable p1, p2. Both of them are of data type pair of integer and string. And we create two objects, one for each, okay? The first one is a pair of integer string that contain 1, so we use autoboxing here to make things easier to read, and the string apple. The second object contains 2, again, autoboxing from int to integer, and then the string pair. We use a diamond operator so that we don't have to rewrite integer comma string here on the right side of the assignment. And we obtain, therefore, two objects that are referred to respectively by P1, P2. And then we want, obviously, to compare them. So we have a Boolean same variable, and we are going to store inside of it the result of calling from the class util. So you see that we start writing the class name because we're calling a static method. So util dot, and I'm going to ignore here the angular braces for a second, util dot compare P1, P2. That syntax would be really like easy for everybody. Okay, we are calling a static method from the class util on parameter P1, P2. That's fine. But now this method is not a regular method, it's a generic method. So we have to specify the type parameter. So the way we do that, and this is a little bit, I mean, this is consistent with the syntax of generic types. Okay, we still use angular brackets and so on and so forth. It's just that it's a little bit weird probably for most of you to see this information come after the dot that follows the class name and before the name of the method. So the idea is when you call a generic method, you specify the type parameters, the actual type parameter, right before the name of the method. And if it so happens that this method is called from within a class or an object or something like that, then yes, it's going to come after the dot and before the name of the method. All right? So this is pretty much the bit of syntax that is a little unusual here. That's how you specify your explicit type parameters. Okay? So it is heavy syntax, again, a recurrent theme with Java, but again, we can actually rely on the compiler to try to simplify this for us. All right, so the way that we are going to get this to be simplified, it's kind of reminiscent of the diamond operator. Okay, the way that the diamond operator allowed us up here, you know, to not have to repeat ourselves when we list the actual type parameters. Well, we have something here that can be used as well. This is how it looks like. So same example, okay, the upper part of the slide is exactly the same example, and you can see that the bottom half of the slide shows how we could have done things without having to repeat actually integer comma string between angular brackets when we actually call the method. So this is working simply because of type inference. So this should be the second time that I mentioned type inference without formally defining it. Hang in there a little bit longer, we are getting to that part of the lecture. But pretty much type inference is, as I already mentioned, the ability of the Java compiler to figure out that in this specific statement here, the last statement of the slide, boolean same equal util.compare p1, p2, well, the data types that are passed as parameter can be inferred based on what P1 and P2 are referring to. So we know that P1, P2 refer to object of class pair integer string. We know that compare is going to actually take two type parameter. Okay, so there we go. This is how we make the jump. Okay, this is how we make the inference. The two type parameters are going to be integer and string. So again, we're going to get into more detail about this, okay? Not much more detail, but still a little bit. But for now, this is all we need to know about type inference and how we need to rely on it to make our code a little easier to write.